Hi, my name's Andrea Callis. I work at Paramount Pictures. I've been involved in archiving for many years, both in sort of in the public and the private sector, both dealing with digital preservation, film restoration, a number of different fun archival projects. So what I'm here to talk to you about today is some work we've been doing at the ETC around the cloud and digital preservation. First of all, just to sort of set the definition, what is the definition of digital preservation of motion pictures? Motion pictures is what I deal with the most at Paramount Pictures, but it could be for any audiovisual material, is what I'm focused on. There is the sort of traditional way of preserving film is, it stays very still. You have a roll of film in a inert can, you put it on a shelf, you put a barcode on it, you set your temperature down, hopefully to about 27 degrees like we do, and 35% RH like we do, so everything stops. Film deterioration stops, color fade stops, you are setting that film in time, and the less you mess with it, the happier it is. That's always been the issue with film preservation, and now, for example, right now, a lot of people want to look at 35 millimeter prints. They're doing that sort of back to the day of looking at 35 millimeter prints, and that's a conversation I have a lot of times where my 35 millimeter print is on its last legs, and it may be the last one I have that's the original cinematographer's view of a film I own, and I don't want to necessarily let it out to the theater, and I have to be very careful with it. So that tension between access and preservation is always part of a traditional preservation approach, film preservation. And then there's the real admin of all that always happens at archive. What we do most of the time is track, because our number one job, as I always say, is don't lose stuff, although I usually use another word. So we have to barcode a shelf, barcode that film can, make sure we track it in a database, know where it is at all time. And the other sort of traditional part of film preservation is migration. Once upon a time there was nitrate film, which was very flammable, made in the early part of the last century. And we migrated that to acetate-based film, which we found out also deteriorates, so we migrated it again to polyester film. But that migration is also a traditional part of film preservation, and that had its own issues too, because with each one of those migrations came generational loss. So something that was a copy of something else was, going to lose a certain amount of definition. And as we've gone into the digital age, of course, we've introduced film scanning and digital restoration tools to get beyond that. But now we are definitely in the era where shooting motion pictures on film and finishing motion pictures on film is a very, very small percentage of what happens. We're shrinking every day. And so, we have to have the same approach of responsibility and care and duty to these digital assets. And so the digital asset is, and so digital preservation, it presents a whole new range of change for archivists. And so it is not about preserving that thing, that carrier, as we call it. So a film could be a carrier of the content, a videotape could be a carrier of the content, for example. In the digital world, there is no real carrier. The object is a digital object. It is not, in fact, it comes off the camera immediately after it's being shot. It moves with incredible speed onto another carrier, and then onto another carrier at a post house. So it is always moving. It is not static from the beginning, and that's sort of the nature of digital. And it's always important. Archivists, I think, always try to respect the nature of the material they're working with. So when we dealt with film, we tried to keep it in that film space as much as possible. And when we're dealing with digital, we're trying to understand the nature of the asset we're trying to care for too, and that's what digital is. So it's that object itself that cannot suffer loss. It's no longer the one frame, 4 sprockets, I can see the key code object that is inherent to that content. It is a much more amorphous thing. It is this object that we need to make sure basically has no bit loss. That's digital preservation, right? We don't want to lose any bits. So how do we do that? And so we worked a lot at Paramount, and I did some of this as well when I worked at BFI before, so I'm working on this sort of in situ for a while, and sort of have come up and talked to other industries, talked to other people doing this, and there are, I think, these sort of basic ideas of digital preservation are pretty, known concepts now, and they are, first of all, you make a lot of copies, as many as you can afford, as many as you can argue to make because you have to store them later. You keep a repository of those copies, of those assets. Very, very careful repository that keeps, for example, information about each particular file. So, for example, a digital intermediate, which is a sort of final film asset, will have, thousands of individual DPX or TIFF frames that make up that final thing. Each one of those files is registered in your repository in some way, The digest for that file, the checksum, hashtag, MD5, whatever you want to call it, is one aspect. Maybe a file name, maybe some automated information about aspect ratio, number of bits, etc. But it ties into other information about what film it is, what particular version this is, other technical information, and in a place like mine, which is a studio whose whole job is to actually distribute those things, it's tied into things like rights databases and finance databases and all sorts of other fun databases. But they connect back to that one object. And the final concept, and the one that we spent a lot of time talking about in the group, is this concept of fixity. And fixity is what I'm going to spend a lot of time talking about next, so I'm just going to keep moving on. So this is the group that got together at the ETC to talk about the cloud and digital preservation and this concept of fixity and how fixity could work in the cloud. And the idea behind fixity is really the actual demonstration of the lack of change, really. So, you want to know, how do you know there's no data loss, right? How do you prove that to people who are paying you to make sure there's no data loss in your database? You say, I have a checksum, a digest, whatever it is, and you then, with your replicates, go and find another copy of that. You check it to make sure it's okay. If it's not, you find another copy of that and flip it out. If it is, you carry on your business. That's a basic concept of fixity. And again, I'll go into it a little bit more. But we really wanted to know, how does this work in the cloud? We have all the fixity concepts have been always on-prem. There's no doubt about that. We'd never imagined the cloud and the distributed architecture that's involved in that. It was very much on-prem storage, usually a lot of tape libraries or maybe servers. But the cloud and its different kind of structure presented this challenge to try to think this through. In case you need some definitions, and I did bring the paper in case anybody wants to see all the details that we went through, these are some of the things that we really talked about in the first part of our conversation to make sure we really defined this concept of fixity really well, because we wanted to have colleagues from the cloud providers also look at these and understand what the hell we were talking about. So part of this is just talking about the fact that we wanted to define, when we say asset, what do we mean? This set of files that represents a film. When we say preservation registry, what do we mean? That preservation registry is really the way that we have collected the information about fixity. We say we went and checked this set of files on this date. they passed, we're good, or we had to flip this out. It is just an ongoing, constant collection of data for that preservation registry. Digest repository. So again, this constantly changing digest, it's a separate tool so that we can constantly make sure we are actually being able to manage that storage policy with whatever either on-prem or storage provider we have. Archive location. There could be different archive locations. There could be an on-prem and cloud hybrid thing. But right now, in our current requirements, we need to know where the copies are. We need to know that we have one copy here, one copy there, one copy underground, one copy there. So that concept of archive locations, again, kind of a challenge a little bit to cloud and distributed architecture, was important for us to define. Fixity, talked about that a little bit, and digest, message digest, and we actually did go through several meetings just defining digest, and again, if you really want to go into all the different ways people talk about hash and digest and MB5 and C4, you can find it in this handy-dandy paper. I won't go into it now. And again, here is just some more information about defining fixity and how it might work. And this, I think that one, sort of workflow is the most helpful way to talk about how fixity works and why it's so important. And I'll start with that verify step because it actually really does happen a lot of times outside of any particular system. There can be some automated processes involved, but basically we spend a lot of time making sure that the film we have is really the film we should have. It sounds obvious, but it's often very much not. So we have a process where we will do things like on the DI file, like we'll make sure that all the file sizes are the same than they should be, or looking for color deviations, looking for errors of a sort of much more bit level in those files. So we do that sort of technical verification. But we also sit in a room with a post supervisor and do a content verification where we look at the DCP as it was distributed in the US, because that's what we do now, and the DI, and we look at them over under. And you'd be amazed how many actual changes are made at the last minute, and it doesn't match on pretty major titles. So that process is a really important one. So all that means that when we actually have gone through all that work and cost and effort, we want to make sure that never, now that we've done that, it continues to be the same going forward. So that's why this process of fixity is important for us. That's one reason. So then we ingest those, and this is the workflow, by the way, that we pretty much follow at Paramount. It's not meant to be a workflow that everyone should follow, but it was an illustrative one that we could use for this requirements explanation. We ingest those into our own homegrown digital asset management system, which has written into it automated processes that do the things like copy those files, send them to different locations, and make sure all of the checksums match for all the copies. And then we set a storage policy on it that says, okay, a year from now, please go and check that and see how you're doing. And it does, and if it's fine, it registers that it's fine, and if it's not, it goes and finds another copy and repairs itself. So we always, in our case, have 4 good copies. And that is the way, we prevent bit loss. That's basically what we do. And this is, just a data model, too, that we put into it for those of you who like data models, to just sort of show what those items are actually doing and how this actual fixity model could the sort of automation of fixity could actually begin to be done in a system. So fixity in the cloud, what we, and we talked a lot about to a number of different people, and Buzz will be talking after me, was one of them, and who spent a lot of time talking to us from different cloud vendors as well. And, the cloud infrastructure, the concept of distributed architecture, the concept of egress still presents a challenge for the concept of fixity as we do it on-prem. So really, the way that we can kind of do fixity right now using cloud in a way kind of as one of our locations, is some concept we're looking at, is we, do this, we upload it, and then we download it, check it, and send it back up. I mean, it's pretty simple, but that is one way of doing it. We're hoping over time there may be some more interesting ways, some more cost-effective ways, some other ways of assuring a lack of data loss. So, we sort of talked about it as kind of the fixity gap, like where do we want to go next? Where could we automate this or do it? And maybe it isn't the same way as we do it on-prem. Maybe we do have to look at different models. We don't know yet, but that's really in the way what the group identified. We wanted to define what fixity was now, how people are using it, and where we see the challenges going forward. Traditional fixity, as that model just showed, in production archiving is like the C4 thing, where we ask everybody in the world to be archivists from the beginning of production. Who's in? Come on. But, that, constant, if we know where everything is from the beginning, absolutely, it's easier to check down the way. Custom cloud solutions, of course, we really hope that there's more attention as people who are trying to preserve assets paid to this concept of fixity so that we can try to figure out how to do it. Object level data integrity services, maybe there's a way to include a digest in our object so that it makes that simpler. We're willing to work on it in these different ways. So we're just skimming the surface, really, of some of the down, and real detailed work. And we want to know more about how cloud and distributed architecture works and how cloud and distributed architecture looks at the concept of data integrity and data loss over time. So that will be, and we hope to find out more about that as well. So yeah, again, we didn't come up with a, here's how you do it solution. We came up with here's where we need to go next, where we could go into really talking more about these issues as we continue to look at them. Again, back to C4, that concept of provenance and tracking that digital asset from the beginning, very, very complex, but yes, archivists like it. Rights, how do we make sure that we are actually talking about something, not only that we can assign different versions potentially to different rights and windows, an interesting concept. Security, always an issue for us, constantly looking at that. I believe that the more we know about a particular asset, the more secure we can be about it. If we know exactly what it is, we know exactly what security we want. Longevity, the concept of software emulation or different file types being read over time. I just have to tell you that I've been doing digital preservation of a type for now about 15 years. I have yet to find a file I can't open, by the way, so I tend to not put that at the top of my just personal story for you all to share. Don't tend to put that, because people do figure it out, and they're really smart about doing that, and it ends up being, but there are people that are doing serious software emulation projects too at universities too, so it'd be a great one to really sort of explain and explore a little bit, because it's one that people really fixate on quite a bit. You'll never be able to open that again. Oh, well, yeah, I did. So migration, media migration, and migration is a really interesting concept. That's how some people do digital preservation today. They do manual migration, right? And by that, I mean you have 50 shelves of LTO tapes, you put them in a truck, you take them to a local vendor, and they migrate all the data off those 50 LTOs onto another set of LTOs. They do some health checks and other things like that, but it's very expensive and costly. But that's one type of media migration. The other type of media migration is happening all the time. It's happening in your clouds. It's happening everywhere. It's happening in our on-prem LTO tape. Even though we have automated processes and we manage the storage, obviously you need new stuff. Old stuff breaks. You got to do that. So what impact does that have on data longevity? How do we manage that? Do you do health checks after a major media migration? We do. So that kind of thing. And then models for 0% data loss in cloud environments, and this is something I hope in the next year or so I will know so much more about than I do now. But it is a really complex concept, distributed architecture, erasure encoding, all the amazing engineering that goes into actually building up the massive cloud storage that exists out there. It's, that the archivist always wants transparency. We want to know, yep, that film, it's in that can, it's got that barcode, I know where the shelf is, I can go there, I can put my hand on it. So taking that and sort of saying, okay, it's good, is, that's a stretch for us. But I wanna continue to learn about that. I wanna know how those things are being approached, because obviously this is everybody's interest to make sure our data and our great films and the world's greatest art form is around for a really long time. So, thanks.